Hello dear students, in this video we are going to see the second example of LEL1 parsing. So we have already discussed the another example of LEL1 parsing in the previous video. So please listen to that as well. So what is the other name of LL1 parser is predictive parser, and let us solve this. So this is the context-free grammar. So before we go into this parsing, first you have to check whether this context-free grammar have left recursion and left factoring. So this grammar doesn't have any left doesn't have any left factoring, but it has left recursion. So what is left recursion? So you can see here on the left hand side, this one, and the see here, this L and this L both are same. So the left hand side and the first symbol in the right hand side both are same. So this is a left recursion. So if we have a left recursion, what is the rule? So for example, if we have a production in this form, so here you can see there is a left recursion. This both are same. So how will you solve this? So this can be converted to A derives beta A dash. So what is beta? The other production which is not starting with A, and A dash derives alpha. The other symbols after A and A dash, and you have to introduce epsilon. So this is how this production should be converted. So similarly, this production, the first production doesn't have any problem, so I'll write as it is. And the next production L derives. So what is the other production which is not starting with L? Is L is S. So you have to use L dash, and L dash derives the other symbols which is other than L. So that is comma and S. So comma and S, and you have to introduce L dash and epsilon. So now hereafter, instead of using this production, we have to use this two production after removing the left recursion. So this step is over. So the next step is we have to find the first and follow. So now let us find the first and follow for this context-free grammar. So I hope you have listened to the previous video where we have discussed how to find the first and follow and all those things. So now let us discuss about it. So first let us find the first. So what is first of yes, when you use this production, what will be the first symbol we'll be getting here? One is open parenthesis, other one is A. And for L, with the first symbol we have is a non-terminal. So you have to derive yes. So when you expand this yes with this two production, again we'll get the open parenthesis and the small a. So again the same thing. And when I see L dash, what is the first symbol? One is comma, another one is epsilon. So here comma, and the one is epsilon. Right? So this is about the first. The next thing is I have to find the follow. So by default for the star symbol, the follow is dollar. And then we have to see in the right hand side anywhere yes is coming. So we here you can see yes is there. What is the follow of yes? The L dash. So L dash is a non-terminal. So we have to find the first of L dash. What is first of L dash? One is comma. So when I replace L dash with its production, the first symbol I will be getting is comma. So who will be following the S? One is comma. So introduce comma here. And then what is the other one for first is epsilon. So when I replace L dash with epsilon, after yes, nothing will be there, right? Because when I put epsilon, epsilon means nothing. So if nothing is there after yes means you have to go and take the follow of L, right? So now I want follow of L. Let's go and find the follow of L. So what is follow of L? So I have to say follow of L is after L what is coming? This close parenthesis. So follow of L is only close parenthesis itself because nowhere else in the here L is coming. So this is the only place. So after L, who is following? Only close parenthesis. So that close parenthesis will also come here. So this is over. So now we are finding yes. So here also yes is there. So if you find yes, what is the follow of yes? L dash. So it is a non-terminal. So you have to find the first of L dash. One is comma. So comma is already there here. Other one is epsilon. So you have to replace L dash with epsilon, which means after yes, nothing will be coming. If nothing will be coming, so go and take the follow of L dash. So now we require what is follow of L dash. So let us find the follow of L dash. So if you see here in the L dash, after this, nothing is coming. So you have to go and find the follow of L. What is follow of L? Already we have learned follow of L is close parenthesis. So I have included that. And here is also another L dash is there. So L dash same production, right? So here the follow is here. So in this case, following yes is L dash. So first is comma, comma is already there. And when you replace this L dash with epsilon, nothing will be coming. Follow, then you have to find the follow of L dash. Follow of L dash is close parenthesis is already there. And for the remaining two production, already we found the follow, right? L also we found. After L, who is coming? Close parenthesis. So that is the follow of L. Who is the follow of L dash? Here it is nothing. So we have to find the follow of L. So follow of L is close parenthesis. That's what we have written. And here for L, what is the follow? Close parenthesis. So we found the first and follow. So done. So the next step, finding the first and follow is over. So after that, what you have to do, by using this first and follow, we have to construct the parsing table. So that is a very important thing. So this parsing table only help the predictive parser to take the decision. So in the table, you have to write in the row wise, you have to write all the non-terminals, L, L dash. And in the column, you have to write all the terminals. What are the terminals we have? We have a dollar, and then dollar is by default, right? Is there. And then open parenthesis, then close parenthesis, then A, and then comma. So these are all the non-terminals. Now we have to say where to write this production. So we have to see the first. So since we have two production for S, when where to place this first production, what is the first of yes? That is open parenthesis. So let us draw the line so that it will be clear for us. Mm. So here in the place of what is the destroyed. What is the first of yes for this production is close parenthesis. Sorry, open parenthesis. So write S derives L. And then for where to write S derives A production, what is first of that? Small a. So in this place we have to write that production. And the next one is this production. Where to write this production? So we have to say the first. What is first of this? Open parenthesis and A. So in the place of open parenthesis and A, we have to write this production S L dash. And here is also L derives S L dash. And now we have to say where to write this production. So this production should be, for that we have to check the first. So for this production, it has the first as comma. So in this place of comma, you have to write L dash derives, comma, yes, L dash. And we have one more production, L dash derives epsilon. So for epsilon, what you have to see is you have to sign the follow. What is there in the follow? Close parenthesis. So in the place of close parenthesis, we have to derive L dash derive epsilon. Right, done. Okay, if you have seen the previous video, it will be very easy for you. It is a very simple one. Now we are given with a string to check whether the string can be derived from this context-free grammar or not. So the input string given for this to do the parsing is open parenthesis a comma a. So, what is the first thing you have to do here is you can understand first thing you have to do is we have to add a, dollar to show the end of the um, input string. And we know that this LE parser have the common end of stack. So, and then we have an input buffer. And after that, we have to say what is the action taken here. So always in the bottom of the stack, we have dollar followed by the start symbol. Yes, here the start symbol. Start symbol means in the production, who is the first symbol? Usually it will be the start symbol. So it is yes. And what is the input to be passed is open parenthesis a comma a, and at the last you have to add a dollar which shows the end of the buffer. Now we have to see what is yes. So what is in the top of the stack? Yes. Yes on open parenthesis. You look at the passing table. What is yes on open parenthesis? So you have to expand S on open S derives, see here, yes on open parenthesis, the production is S derives this. So now S should be expanded with this. So when you push it in the stack, you have to push it in the reverse, then only this will be in the top of the stack. So now dollar yes, instead of yes, you have to expand the S as close parenthesis L open parenthesis. And here we have this. Now, if you see the top of the stack and the buffer both are having the same symbol. So, because of that, what we have to do is we have to cancel it. We have to pop it out. So, what to do further? So, this one and this one will be popped since both are matching, right? And now pop. So after you pop it, what will be there in the stack here? Open parenthesis L. Here we have A, comma A and dollar. Now see what is L on A. So in the top of the stack we have L and in the input buffer we have A. What is L on A is this production. So let us replace L with L derives yes L dash. So when you push it in the stack, you have to push it in the reverse order. So then only the first symbol will be in the top of the stack. So now this L will be replaced by L dash S. So this is this production, but you have to push it in the reverse order so that L S will be in the top of the stack. So now we have to say S on A. So let us write here also what is in the buffer as well. So now we have to say what is S on A. What is S on A? It is yes, derives A. So use this production. So it is predicting correctly which production to be used. So now what you have to do? Now open close parenthesis L dash. This yes should be replaced by A. And what is in the input buffer? A comma A close parenthesis. Now if you see top of the stack and in the input buffer both are matching. So you have to pop. So when you pop, what will be remaining in the stack? Close parenthesis L dash. Here it is comma A close parenthesis dollar. So now if you see top of the stack is L dash, here you have comma. So L dash on comma we have the production L dash should be expanded with comma yes L dash. So now I'm going to replace this L dash. So dollar close parenthesis L dash yes comma. And here also the rest of the things already available. So now here is also comma, here is also comma. So you have to pop both because it is matching. So what is there in the rest? Close parenthesis L dash yes, and here we have A close parenthesis dollar. Now if you see what is yes on A, what is yes on A is yes derives A. So which means S should be now replaced by small a. So we have to say dollar close parenthesis L dash. Here you have to put A instead of yes. And here in the buffer we what we have right as it is. Now if you see both are matching top of the stack and the input buffer. So you have to pop the matched symbol. After that, write the rest of the thing. Close parenthesis L dash. Here you have close parenthesis dollar. Now you see what is L dash on close parenthesis. What is L dash on close parenthesis? L dash derives epsilon. So now we have to expand L dash with epsilon. So epsilon means empty. So when I put it, nothing will be there. And here we have close parenthesis dollar. So now if you see both are matching. So you have to pop it. So what is there in the rest stack? Here it is dollar, here it is dollar. You know already according to the algorithm of LL1 parser, when you get in both the places stack as well as in the input buffer, when you have dollar, finally you can say accept. That means you can able to derive this input from this context-free grammar. So this is actually syntactically correct. That is what the understanding. So the checking process is called, we call it as parsing. So hope you have understood. Thank you. God bless you.